Commissioning of the HVRF. First of all, the refrigeration circuit. So we need to make sure that pipework is all safe and sound. So we need to make sure it's pressure tested and vacuumed. So we're looking at doing a strength test. So we're going to take it up to 45.6 bar. Once we've done that strength test, we're going to drop it down to a tightness test. Take it down to below 41.5 bar and above 37.5 bar. Hold that for up to 12 hours, depending on how convoluted the pipework is. Once we've done that, we're then going to pull a vacuum on the system to make sure we've got no moisture at all. And we're expecting you to go down to around about 2 torr as far as that vacuum goes to make sure it's all nice and dry. And obviously leave it for a little while and see if we're going to lose that vacuum to see if we've got any moisture in the system. Once we're done with that, we'll start moving on to the actual water circuit. Cat 3 filling loop. So connect up the flexible connection. So I can open the water. Then we've got a strainer stopping the debris coming from the mains into the circuit. We've got a pressure reducing valve and a check valve, and that's normally set to around about 1.6 bar, depending on the application. And then we've got an isolation valve and a gauge. So as I open up that pressure, that'll bring it naturally up to 1.6 bar. So filling up the water loop, we'll do one leg at a time. So I open up the isolation valve, let the water into that leg, connect on the bucket to the bottom, connect in my hose in there and bleed the water off through there. Close off the drain point and open up the other valve there as well, and repeat the process for the other legs. Once we've filled up the water circuit and we pressure test that to 3 bar, drop it back down to 1.6 bar, which is our normal operating pressure. We're then going to power up the outdoor unit, power up the HPC box and power up the actual indoor units. Obviously make sure the power supply is all correct. Then we need to get the covers off the HPC box, and we're going to start working on some dip switches to work our way through debris removal and air removal. So the first thing we're going to change is SW51 and 52 both into the on position, and this is going to make the system ignore the drain fault error, because obviously we have a lot of water going into this drain pan as we open the bleed valves. Once we've done that, SW41 into the on position. And now you can see that it comes up saying air 1, and this is starting the beginning of that debris removal process. So what's going to happen now, it's going to start running the pumps in a start-stop manner until it reaches the point of air 2. When the display changes over to air 2, it's now going to run the pumps in a fixed flow, constantly try and force the rest of that debris around and accumulate it into the strainers. Once the screen shows up air E, it's completed the debris removal process. If it shows up ERR, the system's gone to error, in which case we need to restart this process. The most likely reason for this is because of lack of water flow, so make sure you've got the water flow there to stop having that error. Then we change some dip switches to lock off the pumps so that we don't lose all this water that we've just been cleaning. So the way we do that is we change SW41 from the on to the off position and SW46 from the off to the on. Then power the unit off. So once the debris removal cycle is finished, we're going to take the strainer out. And the way we do that, we take the clips off. Now when we do this, there may be some water that comes out of the system. Not much, just the water that's actually in the strainer. By doing that, leave the pressure on it, and so a little bit of water may come out. Then we take the strainer out, and then we can clean it. Once we remove the strainer, we undo that, take the strainer out itself, and we're going to remove any debris from the strainer by running it under a tap. Once that's nice and clean, put it back together again and put it back into the unit. We're not going to need to take that out again. It's not a requirement for servicing. Starting the air removal cycle. So we open up the AAVs on the pipework. We power up the BC box again. We change the dip switch on there from being 4/6 from being on to being off. And then we change the dip switch to start the air removal. SW 4/3 from the off to the on position, and it starts again in air 1. So it's going to run the pumps in a start-stop manner until it reaches air 2. When air 2 shows, it's now going to run the pump constantly at a fixed flow, and this will carry on until it reaches air 3. Air 3. When air 3 shows, it's going to keep the pump running a fixed flow, and it will open up individual ports and blast water through each individual leg. It will do about for 10 minutes for each leg until it reaches air 4. Air 4. So starts opening up the water to all the legs, brings on the outdoor unit, starts warming that water up, thereby forcing more air out of the system. Worthwhile doing a quick little double check to make sure your AAVs are all open at this moment in time and try and bleed off as much air as you possibly can. Then when the unit shows up air E, it has finished doing its air removal cycle. If it comes up saying ERR, that means the system's going to error and you will need to rerun this again. Again, as before, I'll be looking at making sure the water circuit's correct and you've got plenty of pressure there available to you. Once you finish the cycle, we're going to take SW43 and we're going to take it from the on position to the off position to stop that, and you'll see how the LEDs have now changed. Make sure you've got your 1.6 bar in the system, and then you can actually close off the valves because you've actually filled that circuit, and we should have a circuit that's just got water and not air. Next thing we're going to do is double check it, and the way we're going to do that is we're going to put SW45 from the off to the on position. And what this will do, it will run the pumps by themselves, and therefore we can actually listen to those pumps. So if we've got lots of noise in the pumps, we know full well that we've got air still in the system. It takes about a minute or so before the actual pumps cut in. The debris removal and the air removal cycle can take between 140 to 380 minutes. And that variation is due to how many bits of equipment we've got connected to the HBC box, because we're going to test each leg separately. Therefore, less amount of equipment you've got connected to it, the less time it's going to take. If all the ports are taken up, it's going to take longer. Once the water side commissioning is all done and finished, we need to test the system and make sure it all operates correctly. So run everything up in heating, go and have a look at the indoor units, make sure they're getting nice and hot. Then we run the system up in cooling, make sure your indoor unit's getting nice and cold. Then we want to test those indoor units individually. So we put it all up in heating, then we put the first unit in cooling and go and have a look and make sure it's getting nice and cold. Onto the next, onto the next, onto the next. What we're doing here is we're making sure that each indoor unit is actually connected to the correct leg. If it's not, it's going to be a case of looking at addressing. Once you're happy with that, set up the indoor controls and then do the handover to the end user.